the agenda as well. I think you have seen it already, maybe, hopefully. But yeah, that's it. I'm happy to welcome everyone for our first English iteration or English version of our Everyone Can Contribute coffee chats. I've called it Café. I would like to start with a short introduction round before we dig into the topic today, which will be QuestDB. A little bit about myself. I'm a developer evangelist at GitLab. I've joined in March 2020. Before that, I've been in the open source monitoring area for around about 10 to 11 years, maintaining an open source monitoring software. Yeah, and I've been looking into metrics and logs, events, traces all over. And I'm eager to learn new things today and in the future. With that, I would like to hand over to Vlad to introduce yourself a little.
Yeah, thank you, Michael. My name is Vlad, Vlad Ilyushchenko. Just don't worry about last name. Most people can handle it anyway, so it's all good. So I'm CTO in QuestDB, and I'm also been writing QuestDB since 2014. And my kind of day job at the time was algorithmic trading in various financial institutions, primarily banks, kind of fairly big banks. And I've been doing it for a few years, and this is where effectively inspiration for QuestDB came from. That's me.
Thanks. Just pick someone on your Zoom screen who should continue.
Okay, I'm gonna pick. Can I pick another Michael?
So hi, my name is Michael Aigner. I'm from Austria. I'm a product manager and software engineer at the company called ZKW. We are part of LG now for roughly 2 years now. And yeah, my day job is mainly software programming, C++, and this for roughly 15 years now. And also have more and more problems with time series analysis and all this kind of stuff. So I'm really interested to hear about QuestDB. So I choose next Niclas.
Yeah, my name is Niclas Mietz. I'm also not from Austria, but from Germany. I'm currently working as a cloud engineer for QuestDB. Currently, I'm glitching a little bit just because I'm not able to get a right webcam because it's only my iPhone to stream my my picture. Yeah, and there I worked as a cloud engineer, and I'm doing mostly the operating stuff. So working with Kubernetes, monitoring systems like Prometheus, or in some case also InvertLine, and was really curious about this new time series database, QuestDB, and I tested it a little bit already to find how it works and where could I use it in my use case typically. Yeah, and I'm really like to chat about it. So I would vote then for Nicolas.
Hey guys, so I'm co-founder, CEO of QuestDB. And just like Vlad, I come from financial services background, so mostly banks, such as Rothschild, and also at Nasdaq prior to that. And yeah, super excited to go through QuestDB with you guys today. So yeah, I'll pass it on. There is another Nico, right? So 2 Michaels, 2 Nicolas. So I'll pass it on to you.
Yeah, so my name is Nico Meisenzahl. I'm also from Germany, near Munich, so the nearly south part of Germany. I'm doing consulting around Cloud Native, Kubernetes, and just helping our customers to get started with Cloud Native and all the Kubernetes stuff, container stuff, mainly focusing on Azure, but at least I'm doing Kubernetes, so it's the same everywhere. Yeah, so I didn't plan to join this round. At least I planned, but I thought I wasn't able. Now I am able. I'm pretty sure I only go to listen only mode in some minutes, but yeah, really interested in stuff and hopefully learning some new things. So I think last but not least, David.
Well, we'll see about the least part. I'm David Simmons. I'm head of developer relations at QuestDB. I was previously at Influx, so I've got some history with time series databases, and I guess I'm the only one that's in the U.S. right now on this call. So I'll represent North America for us.
Very cool.
Yeah.
Okay, who has the first question, or how? I'm open to everything to continue. If you want to give a short introduction to QuestDB, if we start with integration questions we collected, anything.
So, actually, like not knowing how this is gonna go, we prepared slides. They're not all of them, just very short slides with the kind of subjects we can cover.
Perfect.
So you guys get to know QuestDB a little more. I can just whiz through them and quickly, so it shouldn't take very long. And then hopefully it might lay some foundation for more questions, really. So it'd be good to make it super interactive if possible.
Perfect. Thanks
Yeah,
for that.
be perfect. Thanks.
Cool. Can I share my
You can share a
or
screen, of course.
part of it. Very cool. Right. Can you see this things? Cool. So this is the intro slide. Now you know who we are. I just wanted basically to cover really three subjects here. So what is QuestDB? What QuestDB is not, and various integrations aspects. And then perhaps we can introduce you to demo that we have. If you haven't seen it already, you might have actually. And that's it. So just whizzing through it. So what QuestDB is generally. QuestDB, we kind of incepted this as a column-based store. I guess you guys must be familiar with column-based and row-based approaches, and we picked column-based because it kind of made sense for the time series data. And generally, the reason I'm saying makes sense for time series data because usually data with most volume is time series data, and the column-based approach helps partition this data kind of right from the start. So basically data is sliced into columns, and if data is not needed for a query, it doesn't have to be lifted from disk at all. So whereas in a row-based approach is a little bit more complicated to achieve. Then data that's stored, QuestDB stores data partitioned by time. So time partitioning is, I guess I'm talking to this point, and time partitioning helps us to slice data even further in more meaningful chunks. Generally, time partitioning, the way it works in QuestDB, it's whereas columns are files on disk, and the time partitions are directories containing those columns. So, and the directories, we're kind of trying to be very friendly with the file system. If you were to list QuestDB data directory, you should work out what's what there, basically, like which files to do with which columns, and what columns are to do with what dates, that kind of stuff. And we heavily use time partitioning, which I can explain probably further if you're interested how. So we use it to find time intervals kind of very efficiently, and also we use time partitioning as another like horizontal dimension if we want to calculate data concurrently. Then it's kind of important to know that QuestDB is an append-only system. as opposed to databases where you can mutate data via either update or delete. And append kind of makes it relatively simple to implement, and especially simple to implement repeatable read consistency that comes next. The way we implement repeatable read consistency is we effectively have, if you can imagine, there's a data and then there's position in the data below which any reading code does not go generally. And as data is appended, then this pointer moves down atomically, enabling reading systems pick up all of the appended data consistently and atomically as well. So that's how we kind of deal with consistency. And we also understand that sometimes append-only system isn't necessarily convenient system to work with. So we basically implemented a query on our data that lets you find latest records for a particular criteria. So if you consider, for example, if your data was not necessarily observability related, you could just store changes as one append, one record after the other. And then there's a query system which says, well, I want to get latest for this ID, and I would return you the last row fairly efficiently. And you have a history of all the changes as well if you want to query. And the last point, I guess we try our kind of, I suppose, unique value proposition is performance. We try optimize both data ingestion and retrieval through various means. Well, highly optimized is a bit generic, but what we do is first partitioning, which I mentioned. So partitioning lends itself to parallel query execution. We can process chunks of data simultaneously on multiple threads. That's one thing. The second thing is the data, because it's an append-only system, we effectively store data very densely. So if you can imagine a column, it's just glorified array pretty much. It's just array sitting on disk, and to process this data, we can use SIMD instructions to process this data if we need to aggregate a large chunk of data. And you probably know that SIMD is something that I mean, lets you parallelize execution within single core hardware, so without using threads. So we can execute multiple instructions at the same time. So that's another optimization technique. And lastly, all of our IO around the system is non-blocking generally. So the system does not have like locks or critical sections or anything that it's impossible to lock it up generally, other than have it processed monumental amount of data inefficiently, maybe in some inefficient paths. In this case, it might take time, but otherwise it's a lock and wait free system. So that's I guess that's what QuestDB is. If we move to another slide, I suppose it's important to also understand that QuestDB is not an online transaction processing system. And I say it in a way that our transactionality, for example, implemented so far per table. So it's impossible in QuestDB to commit basically several table updates in one transaction now. We might implement it in the future, but now that's not the case. Likewise, we're not optimized for delete and update workloads. You can have some cases where people absolutely have to delete a record from the database or an update a field on a database. So we not fully optimized for it. So it's possible to update the value generally, but that's not very efficient. And to delete, obviously we tailor delete workloads to time series, as in you delete data in bulk, like old data, you delete old data, but you don't delete records in kind of random records in the middle of the data set. So that covers the delete and updates. And last point, QuestDB is not a data lake. And a data lake, in a sense, we haven't built connectors to work with cloud storage yet. So all the data for QuestDB need to be located locally to computing hardware, which obviously places some limitations on the amount of data that can be processed in a way that they can fit a physical server. So that's the summary. And at this point, I probably would like to welcome if any questions if you guys have so far. Okay, cool. So I'm gonna move on to next slide, which is integrations. What do we have that might help? We saw InvertLine Protocol as kind of interesting proposition. First, there's a lot of tools that send data in this format, and what's kind of I personally found sort of pretty cool that Influx done with this protocol is that you can add the column on the fly. So you don't need to in some cases you don't really need to add the column offline when your data, typical kind of probably relational database, adding a column is the release procedure generally. So whereas Influx protocol makes it really easy and instant, and QuestDB does support it to the fullest. So we can add column on the fly, and we auto detect type, and moreover, adding a column on the fly there is no performance hit, basically adding a column on the fly. So there is, obviously it's not free operation, but there is no data backfill. If you add a column to existing table, it's not trying to backfill the data with nulls or anything like this. And we use InvertLine Protocol for ingestion. We also, on top of it, we kind of enhanced it a little bit by adding optional authentication to this protocol. So it's totally optional, but if you need it, you can have it. And this authentication is a secure challenge response authentication. So that's something that's we think is interesting. And the next point is Influx, sorry, Postgres Wire protocol. And we see that in Postgres Wire as a sort of really convenient feature to get a lot of tools kind of integrating with QuestDB without having to change these tools or program new interfaces. We support most of the Postgres Wire protocol to a point where you can pick a driver off the shelf for any language, and you can definitely execute queries and insert data through the Postgres through the driver. There are some limitations where we don't support all of the features of Postgres Wire, but we don't support like a file upload yet, a remote file upload via the wire, or we don't support like a script execution. And also some of the metadata queries, most of the actually metadata queries that aimed at Postgres may not work correctly, even though we kind of implementing all of these queries to make sure you can get a list of tables, list of columns, and basically navigate the database using Postgres tools. And the Postgres Wire actually is an instrument that allows you to use Grafana against QuestDB using built-in Postgres adapter in Grafana. this basically this Postgres plugin for Grafana, it has two parts. There's one that lets you kind of visually build a query. This part essentially builds a query for Postgres and may not have all the features that QuestDB supports. But on the other hand, this driver also, so the plugin lets you write free text SQL, and there you can write whatever query you need generally, and you can plot the data using Postgres plugin. So these are, I guess these are. On the InvertLine Protocol, I didn't mention. So we actually support both TCP and UDP versions of this protocol. So you can send data traditionally over TCP, or you can use UDP depending on the environment. Some environments have like effectively they prioritize. For example, like there's a system that sends its own metrics for storage, and they prioritize performance of the sending part over the data loss. Like, for example, they would rather send data quickly than have TCP protocol create back pressure into application and slow application down just because it just cannot send the metric out. So we've got both. There's a choice of which one to use, and both of them are fairly high performant applications. We tested kind of UDP InvertLine Protocol, and for very kind of typical message, we process kind of easily over 300,000 messages a second generally on this on a single thread generally. So that's that. Do you guys have any? Did it spark any interest? Any questions so far?
So I got a question regarding to the InvertLine protocol. So which version is it? Is it the version 1 or the version 2?
Because I think it's version. What's the difference between version 1 and version 2?
I'm quite. By myself, I'm not so sure where the difference is, because I was trying to get some Prometheus metrics into QuestDB and transform my metrics from Prometheus to Inverts, and I tried to use it with Vector. Vector is also an ingester for metrics, or it could be also for log files. And there they stated that they support the version 2 and the version 1. So I'm currently don't know where the real difference. I'm currently also checking what the difference between the both protocols and where the compatibility is currently failing.
Okay, I see. So I think this is fairly, we implemented it a while ago. I'd say it should be version 1 at very least, but to be honest, I don't know the difference between 1 and 2 myself. So the whole protocol generally is kind of name value pairs. There's a table name, and then there's a tag value, and then field value, and then the timestamp. Generally, it's a text. We can probably take it offline, and we'll investigate this particular method of sending data from Prometheus to QuestDB and see where the fallout is, and try and figure out basically what does it send. So one important point here is also the QuestDB is we've written the whole thing ourselves. There's no, we don't use libraries for anything. And we kind of fully in control of the InvertLine protocol parser. If something is amiss, we usually investigate pretty quickly and add it generally. So that's the thing.
So I got also second question to that. So is there also support for authentication in the protocol already, so that I can enter username, password, for example?
Yes, it's a challenge response authentication. Generally, it's not a username password. It's more certificate based. authentication, but yes, there is support for that.
Oh, cool.
It's actually, to be honest, when I say there is one, we haven't released it yet, so it's on master, available on master.
Okay.
But it's gonna be part of the upcoming release. But you can definitely play if you build from source, which is relatively easy to do. You can definitely play with it.
Yeah. Thanks.
Cool.
Do you have a Docker container for a dev environment?
For dev, we do not, but this is something right now we sort of we're fairly new to the scene, and one of the things we're working on is a proper CI system to build on multiple operating systems and stuff. And deploying dev Docker container is going to be part of it, but this system is incomplete. We just need to we can push a Docker container from master in the space of 2 minutes, pretty much, but that is manually right now.
Yeah, no worries. I'm just thinking when I want to try it out, and as you mentioned, some features are only in master right now. Nowadays it's super convenient to just have a Docker container and not having to install a long list of dependency manually. I know that this needs a lot of effort to make it right in CI/CD, but I think developers will ask you for that if they want to contribute actively.
Yeah, definitely. But the thing is, you guys may be like that there's a lot of databases out there, and some of them are pretty complicated to install from source. Our database builds in a single file. It's a single file that you run. Like you can download 3 megabyte file and kind of literally double click on it and it runs. You don't need to install any dependency other than Java. Actually, like you need to have Java locally, but other than that, it's fairly easy to get going. But sorry, Michael, go on. Sorry.
No, I was just thinking you might have Java already installed on your systems because of desktop environments or whatever. So it's a fair point to say it's easier to install from source and to contribute than to have whatever Python, MySQL, whatever to be installed to make the application run. So it should be easier to contribute.
Yeah, we actually like all of our development process and actually product is about making it super simple to use from every angle. From building it to build it, you need Maven. So like it's a like one command on Maven, and it produces everything that you need to run. And the file itself is very small. It's like 3.5 megabytes all inclusive database. So, and it doesn't pull any dependencies from anywhere. So yeah, it's and we kind of want to maintain it this way.
Does it need to be an Oracle Java, or can it be, for example, also an OpenJDK?
It can be OpenJDK. It can be OpenJDK. Cool. It's actually need to be Java 11. As far as that, but it can be OpenJDK or Oracle Java.
Cool.
Cool.
And you also have a Homebrew tab to install, not just Homebrew, which makes it easier on macOS as well.
Yes, we do, but the Homebrew is for our releases. So dev, we don't build Homebrew package for the nightly builds, if that makes sense. So this is for released versions, but yes, we kind of do have Homebrew, yeah. But go ahead, sorry.
No, for me, it's just when I want to try things out, I'm hesitant to like call curl and pipe bash or whatever things. I want either Homebrew or a Docker container or a single binary which gets started, because oftentimes your system gets messy after installing lots of things. That's why I'm asking.
Sure. But when we finish with our CI, which would take a week or two, we will have nightly builds from Homebrew and nightly Docker containers.
That's awesome. And I'm also currently looking a bit into the GitHub repository. The building from source documentation is really clear and should be easygoing to get started.
Oh, thank you very much. And not only that, we the one probably this is Nick's usually line, but we kind of very keen to build community and now kind of ethos history to help you guys to do stuff. So we have also Slack channel that you can join, and if there's any questions, we available there to help with anything, you know? Building, using anything.
Awesome. I will be writing a blog post afterwards, and right now I'm also already collecting some URLs and links. So anything you want to share, yeah, just go ahead.
Yeah, so we've got the demo here. Have you seen demo, by the way? Who hasn't seen it? Let's start with that.
I haven't seen it. I would love to see it.
I also haven't seen it.
I've tried a little bit.
Oh, cool. I'm gonna stop sharing this deck in that case, and I'm gonna share my browser screen. That's okay, yeah?
Yeah, totally.
Yeah.
Cool. So let's share another screen. Right. So this is Zoom. This is calendar. Oh, and this is demo. Can you see this demo screen, right?
Yes.
So
Yeah.
this is the URL. It's tryquestdb.io, and it runs on port 9000. So just gonna reload the page, so it's there, right? Yeah. So so what you can do here. So what we have here is a bunch of queries that you can run, and the demo server has like a sample data set as a table called trips, and this is the number of rows in the table. I'm highlighting it. I don't know if you can see it. It's 1.6 billion plus records in the database. So and I'm just going to show you some of the. It's not the biggest database in the world, but it's sort of it's okay for, I guess, for a demo. And one thing is like one the mentioned CMD instructions, right? Like for example, there is this query. It calculates sum of a single column from a table, right? So and this is execution time. It's here I can't select this. Yeah, 211 millis, and then this is the result. This is not a canned query generally, not a canned rather result. So you can run it on any other column generally. But this kind of illustrates, if I run it again, it's probably a bit faster because it's a bit warmer data. So this illustrates the way we kind of execute it. So we would take this column and we slice it in about 240 pieces and execute it using 20 threads, each of which uses AVX 512 instructions. So that's the reason for the performance generally. One other thing which kind of illustrates the partitioning as well, like you can, for example, pick a query. Let's just basically pick this query, right? So this is a filter, and this filter would take all the data that just belongs to this 1 day or 1 month rather, and this is the performance of finding all this records at 2.7 milliseconds. Right? And you can tweak it. For example, if you for sake of argument like find another month, I don't know, month 3, so it doesn't get basically much slower. So you can change this, or you can do, say, you can get entire year for sake of argument. That's the number of records it returns, 110 million in 17 milliseconds.
Are there possibilities to make a time range? So, for example, months 2 and 3?
Yeah, so you can do basically, say you can do months 2, and what you can do is you can do, I think, I don't remember syntax. I think 1 month. I think that's that. So it's gonna do months 2 and 3 together. So like this is the months number 2, and if I go at the bottom, oh, that didn't bottom. Oh yeah, this is the month 3. I don't know if you can see this. It's 2008-03. So this basically, this is a format for implicit range. So this is a starting point, and this is the interval length, right? Or you can do it conventionally. For example, you can do this and
whilst you write, I'll just give some precision on the hardware. It's a C5 metal, but using 16 cores out of 96.
20, Nick, 20 cores. So we can run. This is gonna pick 4 months. So it's, if we go down to the bottom, yeah, and this is the this is the month's number 4, 30s, and blah blah blah. So that's the query, and the execution time is still low, generally 2 millis. And this basically, what this does, it does 2 things. First, the data is partitioned by months, and if the optimizer, when it sees the date range, it tries to first work out partitions that need to be lifted in memory, right? And if, for example, finds there's a top of the partition need to be lifted, top of partition 1 and bottom of partition 2, it knows basically how many rows in each partition, and it just starts lifting data without even searching for things. That's the time partitioning is. If you add like a day, for example, you can add like, I don't know, 03, and you can go say on the time, say 2200. That's just for sake of argument. This will go inside the time column and do binary search to see where the data begins, and that's execution time. It's slightly longer. It's 20 milliseconds because it just does a bit more work generally to do that. And this is the start interval. That's the basically where it began. So that's the interval searches, and then you can do things like I think within Flux you can do this. So for example, and this query, oh no, this doesn't do this. There's the just pick you. Yeah, okay. So this is a good one, right? So what this query does, it takes 7-day interval here and samples counts by 1 hour within those intervals. It's basically effectively aggregation of the data by time, and you specify time interval like this, right? So if I run it, that's execution time. It's a bit longer, 64 millis, but you get hourly counts, and this something you can plot within Flux. Sorry, with Grafana. So you can have Grafana run this query, and it will plot these values, and you can vary this. 1 hour is not a fixed entity, so you can say I want to do by 4 hours just for sake of argument, right? Oh well, it's a bit longer. Actually, there was a network latency here, 18 millis for some reason. But yeah, so yeah, so this does it by 4-hour interval. I don't know if you can see my screen well in terms of like kind of font size and stuff. If you can see all of these numbers I'm highlighting, do shout if you can't see it. Like it's yeah, and it doesn't have to be doesn't have to be hours. So you can do, say, one day. It's basically same thing. So you get fewer days, obviously, because interval is basically 7 days. It's actually add 7 here, so it's 8. So it's a bit of a weird math. So you can do like 6 plus 6, so you can get seven rows, including the first one. That's the count. And generally, other databases like for example Postgres, they would go and I think Timescale posted this article to say, like, we pre-calculate all the different aggregations. Like we calculate by sort of months, we calculate by day, calculate by whatever, right? So this is real time. You don't really need to pre-calculate anything. This is sort of results that you get just by kind of toggling charts. You get response sub 100 milliseconds generally. So it's going to be pretty easy to not pre-calculate stuff. Yeah. So that's this query, sampling query, and these other queries, like this interesting time series query, and what this does. Let me just close this window, stay dangling unnecessarily. And what this does, it takes 1 day of data, right? 1 day of data, and then joins. This is called like as of join, and it joins weather to this data. And what the as of join does, it actually, say for example, the ride was I don't know 10 a.m. in the morning, right? And your data reading could be not necessarily 10 a.m. exactly. It could be like 9:55 a.m. right? And this as of join effectively takes the very latest reading from this table before or equal to the time of event from this table. So it's a fuzzy join. So and this is execution speed of that. So and this is none of it is pre-calculated. It's all real time. So you get 3 milliseconds to get you the result generally. This is in part thanks to the kind of only 1 day selection. If we kind of select like a year, it'll take a little longer, but not too much. Well, I mean, they didn't actually take any longer. So there you go. So and this is actually data you can scroll through. This is I'm just kind of slipping on page down button here, so it's kind of scrolling and stuff. So it's sort of it's actual data you can see. That said, not all of the queries are super optimal. We kind of still need to do some work on optimizer. We need to do some work on the filtering. Kind of, for example, if you filter by amount here, fair amount in the whole table, it'll take longer because the access to the data for the filtering is row based. It's not kind of it's not multi-threaded, single-threaded row based. But we're looking in upcoming release as well. We breaking every query into pieces, and we're gonna make filter multi-threaded. So it's gonna execute pretty much like the queries I'm showing you. So it's not all ideal. So what I'm trying to say effectively, we've got some queries that we implemented. They use row-based access to data and single-threaded. Some other queries have been tweaked to use concurrency and simmed. So even if those with concurrency and simmed going to be way faster than row-based queries. So that's the I guess that's what I'm trying to say. Yeah, so this demo is, as I say, it's live. You can just run exactly the same queries yourselves. And yeah, if you have any questions so far, I'd be really happy to. Sure.
I have one. What happened? What's hiding underneath the chart tab next to the grid?
So
can can you show what's possible in there? So I peeked a little into the live demo already, but I could imagine that many people would love to see graphs and dashboards and other things. And
yeah, so this I just switched there, so it builds the chart automatically from the query you have. It took a while to build it because I included like a year here. It's a year worth of data, and there's 110 million rows, right? It took a few seconds to plot this chart, but this is the this shows I guess the colors here are a little bit off. It shows a fair amount temperature in wind direction on the same chart. It's a bit strange, but you can, for example, I don't know, make it less dense. So it's a year. Let's make it like, I don't know, like one day, I don't know, 22nd of April. And then if I draw this, it's a little bit faster. But yeah, it's not very good. Basically, I didn't prepare the chart, but the idea is you can yeah, you can pick the values from a query, and it would put time series axis, basically timestamp on a kind of x-axis, and all of your non-timestamp values on y-axis. And then yeah, here you can see all these three things drawn on the same scale. That's the problem, like the scale is common. You know.
Maybe show the weather example, like 10 years of New York City weather data. I think this graph is a little a little better to showcase maybe.
Oh yeah, you're totally right, Michael. You know this more than I do. Yeah.
No, I'm just clicking around, to be honest.
Cool. So yeah, so this data, at least this data is comparable in terms of scale, right? So it kind of draws, it draws well. So this chart is not super sophisticated, to be honest. And if you do kind of need more sophisticated charts, this is why we're trying to connect QuestDB to Grafana, because Grafana is a lot better at drawing charts than we do. This is just I don't know, just provide another angle on the data rather than grids, you know. So it's not perfect, but yeah, this is where the data looks pretty cool, just because it's on the same scale. And we need to sort out these timestamps. We're gonna print these timestamps with a lot of zeros, so we'll fix that.
Yeah, I think this really adds something to the interface, because I personally, I can read the long grid with columns and data, but after sometimes you get like tired of it and you want to see some graphical representation. And for quick debugging or for quick analysis, I would say having a simple interface is best, because in my opinion, Grafana has too many options sometimes, and you get lost in the interface, what data you want to see, having a quick look. And I could imagine that if you, for example, have that available with a persistent URL, you could embed the charts into GitLab issues or something else for incident management as well. Not having to install Grafana, for instance, but you have your own charts. And I do know that Prometheus also has a simple web UI based on React, I think. So it's just when you want to, or maybe think of exporting a PNG or even a PDF. This could be super useful if you just query the API and say, hey, I want to have a PNG right now with the latest time series set, which is defined via query. And you don't need any external dependencies. It's just QuestDB and nothing else.
Sure, Michael, thanks. This is the kind of feedback we are hoping to hear more. Generally, is very, very useful. Thank you very much.
I got also another question regarding the notification block. So is there also currently an option in the UI that I can block the notification when I press the run button? Because when you press it a lot of times in a fast time, your browser will be blown by all the notification, how long it takes for a query.
Yeah, You're totally right. So the thing is, we couldn't find like a good piece of real estate where to put this information, and we thought this notification is a good idea. But like, I mean, if we just run it, this is what it just gets overrun by, like, you know, it gets overrun by notifications. We do actually have it on our kind of to-do list to, like, okay, let's find somewhere else, because we kind of keep closing them like you do as well. But yeah, we'll move it somewhere.
Or hide it temporarily by time or something else. Also per button is also enable or disable.
Yeah, it does hide it by time, but by default this time is set to something gigantic. You see this thing is retracting. Like there's like little kind of reducing bar. So it will hide in about 5 minutes, but just generally. Yeah. So sorry guys, we'll find it. We're just annoyed by this thing no less than you do. Seriously, it just covers the grid all the time, covers the part of the SQL text. It's nuisance. But yeah, we'll get rid of it.
Yeah,
cool. But yeah, guys, I don't know. I didn't have a chance to say to you that we're kind of very grateful for you organizing this. It's really good to see that you guys kind of even a little bit kind of interested in what we do, and thanks for tuning in, and yeah, and we wanted basically to help you in some ways, and if QuestDB can be helpful or something works, something doesn't, we're happy to just go ahead and implement things. They, like, just, I don't know if you didn't know, the SQL stuff is part of our code base. It's not a library. Is we're fully in control of the syntax, error reporting against it, and everything and anything here. So we think this sort of time aggregation like that it's a little bit simpler than you would do in other systems, in terms of just you write less text generally. That's the goal. If we can do something to reduce text that you write, it's something that, yeah, something we can, like, just for sake of argument, what we can do is this whole of the select from is optional. I don't know if you didn't know, so you can just run this and it goes in the chart. But yeah, so it just selects from this table. Yeah. And yeah, we can manipulate syntax in a way that makes your life easier generally. And there's also optimizer. We can tweak. Optimizer does quite a lot of funky stuff, like moving around. Basically, the goal of optimizer is to, okay, let me just rephrase it. So the way query is executed is like it's a daisy chain of code. So there's one piece of code that sources data. There's another code that takes kind of input from the first code, and a third code takes input from this second one, and like the daisy chain, right? And the goal of optimizer is to reduce the input from the first source of data, so the consequent kind of pieces of code process less data. So it's the idea. So it's fairly aggressive at kind of restructuring the SQL to achieve that generally. So that's the thing. So we can work on this optimizer to do things even further, and also we kind of, one of the things we wanted to do is to remove headache from trying to, if you have a SQL, then you need to like hint it, create indices and whatever, right? So all of the execution you saw here, it doesn't rely on indexes. So it's just data generally, like you don't need to build indexes or remember to build indexes, that kind of stuff. So we strive to process huge volumes of data really fast. So overhead of maintaining indexes is reducced. We do support indexes, that's said for for really, really big volumes and some complex queries, but generally we kind of try and remove the burden.
I had a question about the I would say unusual way to not using any library. And what are the main reasons? You mentioned that you can build it really easy, but do you also avoid, for example, standard container stuff from the C++ standard library to optimize it more?
Yeah. So the bulk of the bulk of the code is written in actually Java. This is Java. There's a C library built in there as well. So the goal is basically, the reason we try not to use libraries to avoid like a coupling issues, right? So you could have like, you use a library, but it doesn't necessarily take the data in the format you have it. So you've got to like do, okay, you transform the data from what you have it to what the library understands. Now that's the sort of rationale, so that we don't need to do these transformations. If I have the data here, whatever code I write can use this data as it is. You know, it doesn't have to move it anywhere, right? And that allows basically us avoid, in most cases, copying of data. Generally, we don't copying and transformation. That's the main goal, to tightly couple interfaces between libraries that we have. We have libraries internally, but we sort of couple them really tightly so we don't move the data.
So then the C++ part is mainly for SIMD instructions and the calculation a little bit around this. And so the rest is just Java.
Yeah, so basically we use in C we have two things. So for Java usually comes with its own libraries to do with I/O. Like if you need to read a file, write a file, interact with the network, that kind of stuff, right? And those libraries are horrible as far as we can tell generally, right? So we use C layer, very thin C layer, to provide Java with direct access to operating system. So we bypass kind of like, Java is very big on frameworks. Like they've got like an operating system, and then they write their own framework to deal with operating system, right? So we kind of removed, so we imploded the entire framework, and we let Java call like methods like read file, write file, and we keep the signature of the method consistent across multiple operating systems. So that's one reason for using C. The second thing is we do use, I don't know if you guys heard of it, it's basically, there's a guy called Aigner Fogg. Have you heard of him? No? All right, that is this gentleman is I think he's a professor at the uni somewhere, Denmark, or something like that. But anyway, so he wrote like, there's one library that we use is called Vector Library, and this library he wrote effectively C++ templates for vectorizing arithmetic, right? So and because it's basically it's inline templates, it's a barely a library generally, right? So it's just a code that just gets basically inlined in your binary, right? So we use that for SIMD generally. We use that library because it just, if you dig into SIMD, oh my god, it can become complex really quickly because of the CPUs. And also this library lets us, basically what we do is we kind of on the fly determine, basically, like for example, if you have a method that sums stuff, right? When you build C code, we compile several versions of this method for all instruction sets that we support, like for SSC, SSC2, SSC4, AVX2, AVX512. There's 4 of them, right? And we determine which one to call at runtime. Like when you start, we go, okay, this is AVX512 compatible CPU, and all the calls gonna go to AVX512 routine, right? And the vector library that the Aigner created basically lets you template this really easily. So you effectively write same code, just compile it with different flags. It will compile it for ECC2, and the same code would compile it for different instruction set. So it's really, really good. It's not complete. You can't do all things with it generally. So there's few things that we kind of need to extend it for, but generally it's amazing piece of code, and I just can't recommend it enough if you want to use SIMD.
Yeah, that was my next question, because I am in the situation now that I have to build SIMD instruction to a high performance computing system, and this was the question: what do you use, and how do you deal with this many instruction sets? But you already explained it, so thank you for that.
It's amazing. There's probably other libraries that let you do that, but this one does it in a most consistent way. Kind of, have a look. How do I probably can chat on this thing. It's the guy called, let me just type it here. This is his name, and it's called Vect. It's in our repository. Oh Jesus. Anyway,
I think I found it.
Okay.
In GitHub, vcoder/vector class.
Yeah. That's it. Yeah. Vector class 2. Don't use vector class. Vector class 2 is his latest thing.
Thanks for that.
No worries. Yeah, and one other thing we use C for, we basically stole idea from Google's Swiss table. I don't know if you heard of this. And basically it's quite well optimized version of a hash map, and we use it for aggregation generally. And the way it's optimized, pretty much, I don't know how to explain it. So when you store your keys, like in the hash map, right? So what it does, it basically is stores in the hash map, it stores in a dense way a hash code of every key that you have in it, like in blocks. Like for example, you've got 16 hash codes, right? And what you then do, you calculate, if you need to find something in the map, you calculate hash code on the key. And then using SIMD instruction, you search 16 hash codes all at the same time to see which one matches, you know. And then those that you match, basically you do actual key comparison. So that's how it works. So then we use it for queries. Let me just have a look. Average. Yeah, so this would use it. So average distance per passenger count, right? We also use it multi-threaded way. So we kind of build basically 20 hash maps at the same time, pretty much, and then merge them together. But that's the thing, and that's the execution time. It's not super fast, but it's a half a second to do that. You know, it's 1.6 billion rows again. You know, so that's the thing. It's pretty good. And we have our own implementation of that. We basically, I think this map comes from a project called Abseil. It's a Google's project. If you heard of it.
Yeah.
What I found that sort of, I mean, you can use it verbatim, but this project sort of serves almost needs of Google, right? So the way the stuff they templated in it, like, oh my God, we don't need half of it. If you look at this, Jesus Christ, this is a lot of code, you know. And we just implemented our own that again suits our data, and not necessarily we don't need to conform to Google's formats, you know, that kind of stuff.
Yeah.
You know? So that's that. Cool. That's all I really have to show. And if you guys have any more questions, I'll be thrilled to answer any of them if I can.
I have one question regarding clustering QuestDB, because you mentioned it on your website, but it's never documented anywhere at the moment, or I didn't find it currently how I could achieve clustering. With,
Yeah. So the clustering is in progress. So we basically we implementing it. It sits on a branch called replication. It's not fully ready, but it's coming generally. We kind of aim to build a simple replication right now. It's not clustering in the sense of sharding. So it's not going to put half data on one node, half on the other. You're just going to replicate your data across multiple nodes. And we kind of wanted to build it like super efficiently. And when I say super efficiently, so idea there, what we lack kind of stuff and what we're building for clustering, when we ingest data, we ingest data in a row format, so kind of one row after the other, right? And for clustering, we're building column first ingestion. Like it would ingest basically, like if you, for example, have 20 columns, it will insert 20 columns at the same time. It would just basically kind of write those columns independently. And if you have partitions, it will write partitions independently. So, and we build a mechanism for you to, if you have data in this format, so you can ingest basically hugely parallel. And we're building this for clustering. So when clustering going to be sending data across to a node, basically that is a slave, we will send basically all the data, or as much data in parallel as possible. And we're going to leverage this mechanism to ingest it simultaneously in the table. So we just want to make it super fast. That's why it's taking a while, you know.
Okay. Thanks.
Sure.
So I need to check if I forgot anything.
I think we discussed last week maybe showing the roadmap for next year or something like that. So giving everyone a little heads up and an outlook, what's coming, what's cooking.
Oh God, I prepared it, but I need to dig it up basically. So what we want to do is, I guess one thing that's on the roadmap is definitely replication, because this is something that is highly anticipated in database community. We know that this is really really needed, and this is what we're building first and foremost. And yeah, it's going to be open source, so we're not going to hide it basically in a closed source. Then there's a lot of God, I'm sorry guys, I forgot. There were other features that are like super critical.
Vlad, you want to speak about out of order? It's a pretty big one.
Oh yes, Jesus Christ, this is hilarious, guys, because out of order is something I've been doing this morning, continuing to do. I forgot about that, you know. So right now, basically, out of order takes a while. So what the limitation that we have is your data that you ingest need to be in timestamp order. That's the limitation, which we consider to be pretty serious one generally. Yeah. So, and what we're building is ability to insert data in any order, right? And what that means basically is what that effectively means. You've got your target table, you've got your source data. Your source data can be kind of messed up in any way you want, and when you insert it, it will be reordered and put in time series order as it lands in the table. So that's the idea. And this is roughly 50% complete, and we're really keen to finish this. Nick, if you have any other reminders, I'd welcome those, you know, because I'm like, you know, my brain is not thinking well.
Yeah, generally.
I think it's great. Sorry? I was just referring to the out of order idea, because I think we had that problem in the past with, so for instance, you have monitoring system which writes metrics, and then the node is being shut down. And after a while, you have some replication data. So you want to keep the older events, and you also want to insert them into a time series database. And with RRD tool, this isn't possible because you're dependent on the time series inserted in order. With Graphite, you can do it, but Graphite is a little slow in that regard. And I think that could be the same with QuestDB. Am I right?
Yeah, so the QuestDB wouldn't let you do that generally. It would force you to kind of insert timestamp in order. Right now, it's going to refuse, say, cannot insert records out of order. That's the issue. Yeah, we're kind of building something to overcome that, like, completely. And it's going to be transparent. You would insert data via any means you currently do, like InvertLine Protocol or anything else, programmatically, Postgres, anything. And all of these things would use the out of order system. And also we're building it in such a way it will not impose limitation on what kind of data goes in. I mean, for example, you would be able to insert data like 10 years old data together with last second data, and it will go in generally. That's the thing. And not only that, we're building it to be hugely parallel as well. So it's gonna insert multiple partitions, multiple columns split into 3 pieces. Say, for sake of argument, like if you've got 5 columns and 2 partitions, right? It will parallelize this to a degree of 30. So basically, sorry.
I would recommend to put a strong marketing focus on that, because I can see there's a business need with having a replay log or something like that, or MySQL bin log or something like that. And there will always be a possibility to have some old data which needs to be inserted. And I think this is a key feature which your customers and your users will love, I would say.
Yeah. Well, it's the thing is, it's been kind of a little bit of a bane of our lives, this out of order stuff. That's why some marketing at all, we're just excited to have it. And the reason I'm so super excited about it is because I've been working on it for like 2 months nonstop. This is just like, it needs to, I can't wait to see it done. That's the thing. But we sort of, what we do is also like the way we ended up doing it. It's a bit of a trial and error, and I'm sort of very excited to do it really fast. Basically, what we aim to do, we wouldn't be able to insert 1 million records in about under 100 milliseconds. Totally out of order records, right? So it's kind of the tune of 10 million records, out of order records in second. And what's basically interesting there, like there's systems that let you insert data out of order. That's all fine. The problem then becomes these systems do not put data linearly. Like they put them in an index or a tree or something like that. And when you get the data back, what that means is they're taxing every read request to this data because it's just not stored in the order of a timestamp, right? And what we're trying to overcome is that we will tax the ingestion, and we're trying to basically reduce this tax by whatever means possible to make it as fast as possible. And there's going to be 0 tax on retrieval. There's none. So after that, you retrieve data. There's no tax whatsoever. It's going to be as fast as this demo, So it's not going in a merge tree like other databases put it in. So we reorder it on the fly and put it in it. It lands basically neatly in a timestamp order. So yeah, I'm just excited for the tech. I'm not a marketing person at all.
I think I've disturbed Nicolas from saying something before about the roadmap.
No, yeah, I mean, more generally, we're building, features and integration, which will be part of our, enterprise offering, which we call Pulsar for now. And this is going to be part of, sort of open core model approach. And, the idea really is to, one, push QuestDB open source as, widely as possible, and really like turbocharge usage of the free product. And then this enterprise sort of offering will use QuestDB as a library and will be more suited for super large deployments at scale, which we don't currently sort of serve as of today. So that's the sort of idea. And there's a lot around security, monitoring, and also even maybe you want to touch on that, Vlad, a different type of replication, which will be.
Yeah, I think Nick is right, but like this takes us beyond year visibility. So the replication we're thinking of for enterprise product is more geared towards. It's basically CUDP based, the reliable UDP based replication. So it's more geared for setup where you've got servers close together generally, and they service kind of quite a lot of requests together. But rather than sending data over TCP and getting all of the TCP extra kind of traffic, right? So the UDP replication would multicast data to the nodes and deal with NACs generally, and this is going to facilitate faster data propagation generally in the environment that is just kind of where it's going to be the servers basically they kind of connected to the same, for example, switch, right? Like same fast switch, right? So, and this is fairly unique for I don't know if you ever need something like that, but this is takes us to maybe like 18 months roadmap, or maybe 24 even, So our 12 months roadmap is is open source still.
Thanks, that's great to hear. Any other questions we might have? If not, I would like to maybe wrap up or round up. Thanks for attending today and sharing all the amazing insights. For me, it's late now. I'm not trying it today, but I might do tomorrow or next week. And also thanks for all the insights in the roadmap and what's coming next and how to contribute and other things. Really appreciate it. Maybe we just do it next time in a couple of months and see how the progress is or something like that. So just staying in touch. Yeah, and if someone else is watching right now, just reach out on Twitter at QuestDB or at GitLab or at our handles like mine is DNSMickey. Yeah, and just let us know how it goes when you test drive QuestDB. And with that,
thank you guys.